Hi, my name is Raymond, and this video is to introduce my smart HVAC IoT system. And I'm aiming for high distinction. This is type 2 presentation. So, this system is a smart secure building monitoring and control solution implemented with MQTT protocol with TLS encryption. The system includes auto and manual mode for controlling the room condition. So first, in the auto mode, the main logic component here will get the temperature and humidity sensor data for room 1 and room 2. And based on the logic threshold setting, it will publish the command to the HVAC controller for controlling the echo mode for room 1 and room 2. And all the components are communicate based on subscribing and publishing the topics to get the information. And our system also include a dashboard to monitoring and control the room condition. And the concept of handling multiple room aircon mode is very suitable for modern building HVAC management. So next, I will introduce about our main logic design. The first priority is the temperature. If the temperature is higher than 24 degree, the cold mode will implement. But if the temperature is normal but the humidity is higher than 70%, the dry mode will be implemented. But if the temperature and humidity both are normal, the aircon will turn off. So this is the demonstration how the system works. Now the system is in auto mode, and this room 1 and room 2 sensor, they are publishing the temperature and the humidity sensor data to the specific topic, also for the room 2 also. And this is the main logic component. It will subscribe to those topics, and based on the room 1 and room 2 condition, it will do the analysis and publish the data to the HVAC controller topic. And this controller here will subscribe to the topic and based on the command do the response. So here's a dashboard for monitoring the room condition and the AC mode for room 1 and room 2. Now the system is implemented in automation mode. If we look at room 1 here, now the temperature is higher than 24 degree, so the cold mode is implemented. For room 2 here, now the same as room 1, the temperature is higher than 24 degree, the cold mode implemented. So which follow the design logic. And the dashboard here, it also can use to control the aircon manually. Or for room 1 here, if we select the manual mode, the user can select the preferable aircon mode like dry mode, off, or turn the aircon to cold mode. So for the TLS encryption, all the MQTT client and the broker have their own Unicode certificate, and they use their cert and the root certificate to verify the broker. At the same time, the broker also will verify them. So here is the sensor client, one of the sensor client, and this is the broker side for monitoring the MQTT client connection and the message. So now I run one of my sensor client. So we can see that here. Now here is the have a new connection from the on the port 883, which proves that the system are using the TLS encryption for the MQTT. So here is the SC alpha, and I've used it to set the different access level to the topic for the different MQTT client. So here's the setting. Start from here. This is the room 1 sensor and room 2 sensor, and this is the main controller component. It's a HVAC controller, and this is just now the dashboard setting. And here is the MQTX. I set the access level to only to the room 1 and room 2 room condition data only for the temperature and humidity, which means that it can access to the logic command topic and to get the command message. So here is the MQTX. Now it's connected to the broker LVT and subscribe to all the topic. But here it only can capture the temperature and the humidity sensor data for the room 1 and room 2. So next, about the related engineering spec project. This semester, I involved in a transmission line design project, and this HVAC IoT system can contribute in maintaining transmission line temperature to prevent server fault occurs and the city blackout. If the temperature increase or decrease a lot, the system frequency will become unstable and easily cause the fault occurs, especially in Malaysia. The weather is changing very fast, so maintaining certain temperature is essential. Thus, in this case, the encryption of the sensor data and the logic command will become very important also. Without a proper encryption, the malwares can easily amend the MQTT message to cause the IoT sensor and the system have a wrong analysis and the command, lead to the wrong temperature also, and cause the power system get damaged. And the cost is extremely high. Therefore, the IoT TLS encryption can help to secure the message and prevent the unauthorized access. In this conclusion, the IoT system is very suitable to apply on transmission line application for the temperature maintenance and the data encryption. And that's all for my presentation.